Another iMachining enhancement in SolidCAM 2020 is a new machines category that's been added to the iMachining database. Let's take a look at this new feature and why it was designed. Here I have an example mill turn part opened, and in this case, the machining will be performed on an Akuma MacTurn 250W multi-axis mill turn machine. Prior to SolidCAM 2020, it was often a challenge to define iMachining operations on these types of machines. The reason being is the iMachining technology requires information about the machine to provide cutting conditions that are optimal for each operation. That information comes from the machine database selection in the CAM part definition. It includes, but is not limited to, spindle speed max, feed rate max, and spindle power max parameters. In SolidCAM 2019 and earlier versions, it was only possible to define standard machines having constant machine parameters, like we see here. In mill turn machines like the one I'm using for this example, these parameters vary when you have two or more submachines or active tool part cutting pairs. Now in SolidCAM 2020, added to the iMachining database is the new machines category defined by VMID that supports the varying parameters and VMID kinematics of two or more submachines. For example, I'll right-click Defined by VMID in the Machines list to add to its category a new machine, and I'll give it the same name as my selected CAM part CNC machine, MacTurn 250W2S. In the properties, you'll see that all machine-related parameters are now set to 100% of the VMID values. Every iMachining operation upon selecting the tool can now be given the exact values of the relevant submachine being used and, in turn, can provide the appropriate cutting conditions calculations. After clicking Save and Exit, I can select my newly added MacTurn machine from the Machine Database drop-down list. I'll click OK to confirm my changes to the CAM part definition. So the question might be, from where in the VMID is iMachining taking the values? In the SolidCAM Manager, I'll double-click my selected CNC machine. This opens the Machine ID editor and displays the corresponding virtual machine ID. The VMID defines everything SolidCAM needs to know about the machine and more. For iMachining specifically, the Defined by VMID feature takes the values from the machine definition. In this case, we have two turrets of different types that have varying parameters. Axes may have different max feeds, for example. In this case, spin max differs, and in some cases, power max can also differ. Efficiency is taken from the station's data, which can differ as well. In this case, there are 4 submachines. iMachining determines which is being used and sends the correct values to the operation. iMachining also handles the sending of correct values to operations that can be performed simultaneously on mill turn machines having multiple channels. As you can see, this new Defined by VMID feature can be used to create machine entries in the iMachining database for your most complex mill turn machines. Furthermore, this new feature simplifies overall the machine database definition and selection requirement for iMachining. Let me go back to the iMachining database for a moment. In some cases, it may even be possible to create just one new machine and name it, for example, Global Machine. A global machine entry could be quickly and easily paired with any CNC machine, whether it be a mill turn or milling machine, making for just a single selection in the CAM part definition.